Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, section 1.1, problem number 55. For this problem, we're given a graph and we're supposed to write the function for this graph. So it sort of looks like an absolute value function, but we have two different slopes, so it's not quite an absolute value function. It looks like it's more so just a combination of two linear functions. So here's what we have. Let's see. Let's just write some of the information here. It looks like we have a slope of -1 right here, and it looks like we have a slope of +2 over here, okay? It looks like the graphs have a pretty significant change right at x value x equals 3. And it looks like it goes all the way until 5, x equals 5, and it ends right here at 0. Okay, so with that said, if there's not a simple, quick, absolute value function that we could do for this, then this is most likely going to be a piecewise function. And so we will write f of x equals, and there's going to be two pieces to this. Well, the first one, it does have a slope of -1, so this is going to be in the form y equals mx plus b. And these are both linear functions. So y equals mx plus b, m is -1, so it's going to be -x, and our y-intercept here looks like it's at +3, so -x plus 3 is our first one. Our second one, there's no intercept, at least not that we can see, but it does have a slope of 2x. I'm sure if we, hypothetically followed this line all the way down, we would run into an intercept of some sort, but we don't need to worry about that because this is going to be a piecewise function. So it's just going to be 2x there. And now, well, -x plus 3 and 2x, but under what conditions, right? Well, looks like it'll be -x plus 3 if x is greater than equal to 0, less than equal to 3, or 2x if x is greater than 3, less than or equal to 5. And that's pretty much it. It looks like I wrote 3 twice on accident. That should just be an x. Here we go. If you're wondering, well, how did I choose about these 3's, right? Like, how do I know if it's greater than or equal to, or just greater than with respect to these 3's here? Right, because this is where the graph changes, is right at this point here at x equals 3. And to be honest, I don't actually know because it doesn't tell us. That information isn't provided for us. So I just picked one I picked one line segment to include 3, and then I decided to have the other line segment not include 3. That way there's no debate between the two. What's probably more important with this problem is just making sure that we get these equations to our line segments correct. That way we can properly describe the graph. I would think that that's most likely a little bit more important than making absolutely certain that 3 is, shared between the two graphs. So anyways, that's it for problem 55. It's a quicker problem than some of the other problems that we had previously.